The last part for this section deals with solving equations that are in quadratic form. Well, what does that mean? Well, that means that you can look at the first term and you can rewrite it as maybe something squared. The second term would be just the linear part of that, and the last thing is a constant. So it looks like it wants to be a quadratic, but it's not exactly. So how do you solve these? First, get yourself into general form. Again, that means all terms on one side, 0 on the other side. So 0 on the other side, terms on one side. Then you make a substitution for the original variable that's going to make the equation into a quadratic. So it's going to make it look kind of like this. So we're going to substitute, we're going to just pick a letter, and we're going to substitute. Then we're going to solve the new equation by factoring or using the quadratic formula. Then we have to substitute the original back end and then finish solving for our variable. And finally, check our answers, get rid of anything that doesn't work. Let's look at example 7 and do one of these problems. So step 1, get yourself in general form. Am I in general form? I sure am. All terms on one side, 0 on the other side. Step 2, make a substitution. Let's take a look at what we have here. We have x to the 4th minus x squared minus 6 equals 0. Looks like it kind of wants to be a quadratic, but it's not exactly a quadratic. Do you agree with me that I could rewrite this if I wanted to as x squared quantity squared minus x squared minus 6 equals 0? Well, yeah, I can, because power to power, right, rules for exponents. Well, that would just multiply and get me x to the 4th anyway. So I haven't really changed my problem here. Okay, I'm going to make a substitution for, and you're always going to want to make a substitution for your variable and that exponent in the middle. So we're going to pick a letter. I'm going to use the letter J. We're going to say let J, but we're going to let J equal what's in the middle here. Well, what's in the middle here is an x squared. We're going to let J equal x squared. And then what we're going to do is we're going to rewrite this equation in J's no longer in x squared. So instead of x squared squared, I'm going to write J squared minus, again, instead of x squared, I'm going to write J minus 6 equals 0. So notice, I can make a substitution and then get it into a quadratic, right? Because j squared minus j minus 6, that's a quadratic. So I can solve that using factoring or completing the square or quadratic formula, whichever I'd like. So let's actually solve this. I'm going to solve this by factoring. If I factor this, let's see, only things that multiply to a j squared is j and j. Then I need to multiply to a negative 6 and subtract to a negative 1j. So that would be a minus 3 and a plus 2. Let's just check. J squared plus 2j minus 3j is a negative j, and then minus 6. Great, that works. If I set both of these, I should say equal to 0. I have j minus 3 equals 0, and j plus 2 equals 0. But do I care about j? No, my original problem was in x's. So what I need to do now is put this x back in place of the j's and finish solving. So I have, instead of j, I'm going to write x squared minus 3 equals 0. And on the other side, again, instead of j, I'm going to write x squared plus 2 equals 0. Right? So what did we do so far? We got into general form, we made a substitution, we were able to factor it as a quadratic in itself, then we are now solving, but again, I don't care about j's. My original problem was in x's, so I had to stick the x's back in. So now I have to solve x squared minus 3 equals 0 and x squared plus 2 equals 0. So let's look at the one on the left. Well, this is a binomial. Does it have a GCF? No. Well, how could I solve this? Well, I can do this by extraction of roots, right? So I'm going to isolate my x squared. So x squared is equal to 3. Then I can take the square root of both sides. So the square root of x squared is just x. And remember, when you take the square root of both sides to solve an equation, you have to write plus or minus. Can I simplify the square root of 3? I can't. So it's just x is equal to plus or minus the square root of 3. All right, other side, same thing. I have a binomial, no GCF. I can solve this by extraction of roots. So I need to isolate x squared. So I'm moving 2 to the other side, and I get x squared is equal to negative 2. Take the square root of both sides to solve this, and I get that x is equal to plus or minus, well, the square root of negative 2, remember, the square root of negative 1 is I, so I take that out. And then can I simplify the square root of 2? No, so I would leave it there. So I get, for the second answer, I get that x is equal to plus or minus I root 2. Let's talk about the checks here. Really, the checks for these are not necessary unless you've got something like this where you're taking the square root. So it's because here I don't have anything where I'm taking the square root. The checks here really aren't necessary. It's not that we can't do them, and if you want to watch me do the check for both of these in class, just let me know. It's just going to make the video really longer. I will do the check over here for the square root, but again, when you have polynomials like this, where it's x to the fourth, x squared, where you're not raised to any kind of rational exponent, or you have a radical, you don't really need to check. So we can add this only to rational exponent or radical original equations. So only when you have a rational exponent or a radical in the original equations do you really need to do step E. Alright, so that means that our solution set for this guy down here is plus or minus root 3 and then plus or minus I square roots of 2. Great. What about this one over here? Alright, same thing. Step 1 is to figure out if I'm in general form. Well, am I in general form? Yes. All the terms on one side, 0 on the other side. Great. Now I need to make a substitution. I'm telling you, the substitution is always going to be for variable and power over here. Well, I have the square root of x. Ignore the coefficient. It's just the square root of x. So let's pick another letter, something else. What about w? So I'm going to say we're going to let w equal the square root of x, because that's what's in the middle with variable and power. Well, do you also agree with me that I could rewrite this equation like this? Instead of writing it as x minus 2 square roots of x, I could really write it as the square root of x squared minus 2 square root of x minus 8 equals 0. Isn't that the same as the original? Yeah, it is, because the square root of x squared would just be x. Well, that might be really helpful in order to do the substitution, because I said that w was equal to the square root of x. So that means now wherever I see a square root of x, I can stick a w. So I could rewrite this equation as w squared minus 2, again instead of the square root of x, I write w minus 8 equals 0. Am I a quadratic that I can factor or solve now? I sure am. So let's go ahead and factor this, because it does factor. W squared minus 2w minus 8, no GCF. W minus 4 and w plus 2. So I get w minus 4 and w plus 2. So set each one of these factors equal to 0. And then you have to remember that you don't care about w. You care about x. So you got to get rid of the w's and place the original back in there. And remember, w is equal to the square root of x. So now I rewrite it as the square root of x minus 4 equals 0. And then the square root of x plus 2 is equal to 0. Great. Okay, let's solve these guys. So how do I solve radical equations? Well, if we look back at, I think that's video number 2, well, it says isolate. So isolate this guy. So add 4 to both sides and I get the square root of x is equal to 4. Then I need to get rid of the radical, raise both sides to the index. My index just happens to be 2 because it's a square root, so square both sides. Cancels on the left, and x is equal to 16. Great. Now let's solve the other side. All right, same thing. Isolate the radical, so subtracts 2, and I get the square root of x is equal to negative 2. Got to get rid of the radical, so raise both sides to the second power, and I get that x is equal to positive 4. So my two answers so far are 16 and 4. But the original was a radical equation, right? The original was a radical. So remember, when you got those rational or radicals as the original equations, you have to check. You have to. You can't not check. Why? Because I like giving you the questions that if you don't check, you get them wrong. So just get in the habit. If that original, when you're doing quadratic form, has a radical or a rational, check it. Let's check x equals 16. So I have x, which is 16, minus 2 square root of x, which is 2 square roots of 16, and then it's minus 8. Minus 8, and I'm asking myself, does that equal 0? I don't know. Let's figure it out. Well, square root of 16 is 4. Minus 8, does this equal 0? I have 16 minus 8 minus 8. Does that equal 0? It sure does. 16 works out just fine. Let's do the other one. Let's do x equal 4. Okay, so same thing here. I'm going to have 4 minus 2 square roots of 4 minus 8. And I'm still trying to figure out, does this equal 0? I don't know. Well, the square root of 4 is 2. It's 8. Does this equal 0? So this is 4 minus 8. Does that equal 0? No, 4 minus 4 cancels, and negative 8 sure as heck doesn't equal 0. So I have to discard the answer of 4 because it's an extraneous solution, and my only answer is 16. Well, that's it for miscellaneous equations. Again, for this last one of equations in quadratic form, you have to get yourself in general form, make a substitution, solve that new quadratic by factoring, completing the square, quadratic formula, whatever you want, then put the original back in, and finish solving. And again, the only time you need to check it is when that original equation was a radical or a rational exponent.